Hello everyone, thank you for attending this presentation. I'm very sorry I could not deliver it in person today. My name is Julien and I am a PhD candidate in educational technology. Today I will be presenting the results of a comparative user test on the impact of geolocation data on usability, exploration and focus in location-based augmented reality. This study is part of a wider research effort to understand the potential benefits of location-based augmented reality for biodiversity education. AR interfaces offer many interesting features for education, such as an increase in motivations by pupils, but also the ability to deliver contextual information in real time. However, they also have limitations. We're researching location-based AR, which relies upon geolocation data, which as of today is quite limited in accuracy, causing the anchored objects to jitter or drift and various usability issues. We developed biodiversity, which is an open source web application featuring a cartographic authoring tool for location-based augmented reality. It was primarily imagined for teachers, students, and citizen scientists, and is structured around the management of thematic AR environments that users can create, join, visit, and duplicate. Users may create or edit points and lines of interest and populate them with media. In AR mode, these media are triggered based on user location. The app enables geolocated traces logging, where each user has access to and may visualize their own data. In the following study, we wanted to evaluate the overall usability of our application, but also explore how various geolocation data impacted usability, exploration, and focus. We designed an environment using our tool and split our participants' sample in two groups. An experimental group used the app in combination with an external real-time kinematic device, supposedly getting centimeter-accurate geolocation data. The other half used the app with the mobile device's embedded GNSS data, whose accuracy supposedly ranges from 1 to 30 meters depending on the environment. During the test, we recorded the accuracy of the data each participant were exposed to. We also logged the participants' traces and their interactions with the app. Participants wore eye-tracking glasses to record their gaze and focus. After freely exploring the environment with the app for 15 minutes, they were asked to answer usability questionnaires. We computed the average geolocation accuracy users were actually exposed to. Because in AR, continuity in the data matters just as much as peak accuracy, we also calculated the standard deviation. Additionally, we removed and counted outliers in the data as another indicator of continuity, since these outliers cause jumps in the interface. We computed the distance walked by participants to compare exploration. We also looked at the amount of points of interest they visited and the number of times they opened the interactive 2D map for navigation. To evaluate and compare focus, we extracted the frames from the eye-tracking videos and trained a vision transformer model to differentiate those where the gaze point was located within the tablet screen or outside of it. This allowed us to calculate the ratio of time each participant spent interacting with the screen or with the surrounding nature. Finally, to evaluate and compare usability, we calculated the scores from our usability questionnaires. The results show that the data accuracy was significantly different between the groups, but not in the way we expected. The RTK group was exposed to data of lesser quality, whether in terms of average accuracy, continuity, and in the amount of outliers found in the data. Looking at the traces, we realized that GNSS data seemed to feature a filter that pre-processed the data and removed most of these outliers. Because RTK data is meant for professional use, it delivers raw measures with loads of metadata. This is why it contains so many outliers, which had a negative impact on accuracy. When comparing exploration, we note that the GNSS group walked longer distances than the RTK group, which would indicate they were driven to explore more efficiently, possibly because they had an easier time navigating. Looking at focus, we don't note any significant difference between the ratio of time each group spent interacting with the screen, but we do note that the overall ratio sits between 69 and 73%. We consider it an interesting measure to monitor the role and dominance of technology in this type of activity. Even if the situations are too different to compare, we did observe an average 88.5% of screen interaction in a previous experiment with pupils in 2017. Finally, the GNSS group reported higher usability scores in all 9 scales, 5 of which were found to be significantly different. Since we realized they were eventually exposed to the most accurate data, this indicates that accuracy does impact positively usability in location-based augmented reality. The full results of this comparative study on the impact of geolocation on usability in location-based augmented reality are available in the feature article. In a future study, we will evaluate the efficiency of using location-based AR against traditional, non-digital methods for learning concepts on biodiversity. In the future, we'd also like to explore the use of a 7-parameter transformation algorithm with computer vision data and GNSS to estimate user location and heading more accurately. Thank you for your attention, and please feel free to contact me if you have any questions or advice.